Recording in progress.
Yeah. So today's too much work. Maybe my system get a hang in between. Cool. Like the next thing is we're moving towards the prompt engineering, right? The prompt engineering. So basically, in real world systems, in the production systems, we use this technique. So why I'm before telling this before we're deploying any LLM, because this actually lies before your LLM only, before your LLM. So if we go here in our syllabus, I mentioned here, is it okay now? Hello, hello, check, check my voice. Cool. If you see this section, prompt pattern and techniques, prompt version and templates, and testing frameworks, and there's real prompt things will happen in the your LLM. Okay, so it is not like we are doing an POC. The LLM was okay in the notebook, and we're deploying. But when it is deployed, it is your responsibility that how your LLM should behave. It's not only about the training. See, I had an LLM here. Okay, that is nice. So what I will be doing, have this LLM. This LLM I have deployed. Okay, it is working. I had some training data. So with some training set data, I have trained it. Have trained it. I have trained it okay. In my testing, in my testing, I only pass inline prompt, right? In last lab, what we have done, we only passed inline prompt in the notebook. For this inline prompt, it is giving a response, right? But when this you deployed, when you're really getting the user request, when you're getting a user request, a real user request from the internet, and you have here web web UI. So how it is going to manage and how it is going to reach to this is, are you going to give a plain prompt of what user is giving? No. Are you going to give a plain prompt what user is going giving to your website? No. So there would be a some technique. Here there will be a backend. There will be a backend where we do prompt prompt management, templates, we do versioning. So if you are running two or three models in your production systems, you will maintain this. You're running 3 4 LLM models from your this side. In the back end, you maintain this one actually for your internal and for your customer face, because your domain specific, your LLMs are domain specific, your responses are domain specific, right? So if I go and ask, go to the Cisco website, I went to the any Apollo website. If I ask about the, hey, create the image, does it will create the image for me? No. If I ask about a bike in the Apollo website, the chatbot, will it able to answer about the bike? No. It is up to that domain only. the response, whatever the prompt you are giving to it, LLM is having that mechanism actually. It can react to anything. Any prompt you give, it will react. But if you pass that, since your LLM is already trained on billion parameters of data, also you did some training with your domain data, maybe sometimes it can be able to give you response on it. But that is not the thing. So it has to give you response on what you have defined. Your inputs, your input prompt, where here go, here it has to formulate it. It has to populate in a nice way and then send it to the LLM. Here only in your backend API, you have to do this. So this is a separate microservices, guys. Okay. So this is a separate microservices. Microservice. We have a separate repository for it, and separately we maintain a registry for it, and we will run this testing also, this prompt testings, and then we will deploy it here. So this is a real world issue. This is a real world issue. If you are not maintaining this prompt management properly, your LLM can give you wrong things. Your LLM will give you wrong things, and there are many cases that recorded from Notion itself, this big company, and Apple, and also this company called uh, this one Spotify, and so there are already public cases are already there in the internet. You can search also. So there are some cases are already done whether when their LLMs are behaving very weird, because this LLM is not the problem that time. LLM was pakka, okay, perfect, scoring perfect, benchmarking perfect, everything is perfect. It's working okay when you're doing from the engineering point of view. But when you look at the customer point of view, it is actually not doing a proper thing when you're running this. Why? This is a problem. This is a problem actually. So that is why I'm telling this is also important, because once we deploy this, we we might come to this point or not. So I wanted to cover this because we only deploy and we will expose with an API. In the API, we will just write inline prompt only. That's it. But we will never maintain this as a separate microservice. So we will create a separate repository in the real world organization. In the real world organization, here we will maintain actually. Here we will maintain versions, templates, and all. So this prompt to understand there are some techniques. There are some techniques in the prompt. So what are those techniques? We know that prompt is nothing but the way we are communicating with AI. Okay, your prompt, the better prompt, the better output you get from AI. The better prompt, the better output you get it from the AI. Right now, however, user is not in our control. This user can give anything, but the response is in our control. The response is in our control. So how can formulate this and design this prompt and then send to the LLM. That's where this backend API is backend service. So this prompt management will be not in the UI or not in the LLM. This is a separate layer here. This is a separate layer, and we will monitor from this section how it is. We have some tools also here for monitoring. Okay, we have a tools as well for monitoring purpose, like Azure Prompt Flow. Okay, we have Langsmith. and prompt flu, that's also there, one more tool. Okay, so like this we have a tools there for the specific job. They're selling this as a product. They're selling this as a product. When the LLMs got crazy, they're selling these tools as a product actually. So here we are able to monitor what users and how this LLM responses and input stage inputs are coming. Everything here it is going to log. This is one thing. Any LLM that we are building, this is also one thing. Okay, so what are the techniques that, see here, here one lab also there I built, because we need to follow a better LLM response. We have these techniques. It's up to you which technique that you want to use, but at least make sure use a 2 3 techniques in combination, and you have to test it whether it is working perfectly on your system or not. The first one is zero shot. Even whenever you are trying to communicate with the cursor, when you are trying to communicate with the copilot however is not good, even you give a very good prompt. So cursor or any windsurf or lovable, bolt, replet, okay, and you have Kiro and you have other things, okay. When you are starting communicating with any of this Anthropic, we have this Anthropic Opus Sonnet, right? ChatGPT 5.4 and Codex. So with the Codex also, when you're trying to interact, because these are coding platforms, you should follow this as well. Okay, this is however inside the system, but you can also apply while you're communicating with any chat GPT or a chat bots. Zero shot is a simple and well defined task. That means we never write any blah. We directly ask what we want. That is called zero shot. So in that case, your chat GPT will give you lot of blah things, right? Because there is a control mechanism in your chat GPT. You can actually restrict it. So when you say a single line, ChatGPT will not only give you a single line answer, it will write at least one para to you. So not to do that, you have to go to settings, say something, or you have to say inside the ChatGPT only in the prompt. Okay, that is a control thing which is given to you as a user, because they don't know what to control you. That's why they given this control kind of things to you itself, that you can do whatever you want. You can apply rule settings over there. ChatGPT has to give you response in this pattern. Like if you're working on a DevOps, if you're working on a QA, if you're working on a AI, so say that ChatGPT that only give me AI content. Whatever I ask, only relatable to the AI and give me that. You can do that. So zero shot, when you keep this prompt in your system, it will only write the exact answer for it. And few shot is nothing but you are doing and you are formatting that in a classification mode. Okay, in a classification, classifying them. Example, I would say chain of thought. Chain of thought where your Gemini and other things are chat GPT, and as well as your Anthropic, Grok, everything is working because the reasoning, math, logic, and task. When you give chain of thought in a sequence wise, it thinks and it give it to you step by step, step by step. And one more technique called re and act. So re and act where actually your lang graph and your crew AI, where you keep your LLMs to work like an agents. So this is the technique there we use it. Connecting the tools. Connecting the tools, we use this. And self consistency. So this is, it generate a number of answers, but it will pick one majority of the answer which is having high score. And tree of thoughts. If you given very big long coding problem, you given very a big log from the system generated log. It has to find correlations with it. it has to find map the things, and then it has to reason, then it has to calculate something, then it has to give you that this is a RCA, root cause for this error. So in that case, this prompt will help you because it will think in a multiple directions, not in a single direction. It will think in a multiple directions and try to bring up as a one unified answer for you. So that is for tree of thought. Persona is nothing but is like your specific to your content intent, is specific to your intent. Okay, so whatever your intention you have on a domain specific, or it is a tool specific, or a subject specific, or a any doc specific, then you can go with this. So output structuring, this is where we can say that the output should come in a JSON, YML, XML, or a normal text format, or a normal text format. So these are the core techniques. But see, format, how output formatting, however it will be there, we will be defining. Persona is also important. Tree of thoughts, okay, it's an optional. Self consistency is also optional, but React is an optional if you are only an LLM. If you are going with a tool connection and agent, it is important. Chain of thought is important. Few shot is important, and zero shot also important. For this, we will write the versions actually. We will write versions actually. So before that, let's have some examples here. How does this zero shot will look like? This is look like this. So in the inline code, we give it like a prompt. There's a problem actually. The problem is I'm getting multiple tickets from a Jira, or I'm getting multiple tickets from a service now, and my system is here. My system LLM is here, okay? My LLM has to react on it. So for my LLM, I need a standard prompt to it. A standard prompt where my LLM can understand what should I work. So that is where this zero shot classification will be. Let's say classify the following support tickets into exact one category. There are customers are continuously logging tickets from Zendesk, continuously logging multiple tickets from the Zendesk, right? Number of tickets, customer based, we have project based, and we have service based, like that. So bunch of tickets are coming upon, and some people are doing through the call, some tickets are coming through the IVR AI, some tickets are coming through the they trigger it from the portal, some tickets are coming by agent, okay, internal agent. Agent means they call to the human front desk guys or application support team, and they'll say that log this ticket. People will manually log the ticket. We have three sources from the Zendesk. Tickets are logging, okay, tickets are logging, okay. Now uh, my support team leader wants to know that how this many tickets are logged, so we have an AI system where it will say that to the team which tickets we actually need to take an attention. So how can I say that every time? Do I need to every time give a prompt? No, this is an automated process. There is no UI, no chat window we will get. In the system, everything has to work in a backend. So that in the backend API, where our LLM is going to connect with your Zendesk, in between this will be there. So we will say that classify the following support tickets into exactly one category. Category will be billing, technical, account, or general, whatever. A ticket title, okay, example. I can't log into my dashboard since the update. Then it will only return the category name, nothing else. It only return the category name, nothing else. So this is a zero shot. Direct. We want only what is a category Which category? Billing, technical, account, general, which category it is. So that category only we will get it as an answer from my LLM. Okay, from my LLM. So this is the a use case of the zero shot classification. I just added this use case like classification. You can keep anything. I have added this use case. It's a real world use cases, am and few shot. So what this few shot is, so I wanted to guide my LLM with some examples to give it a better output. Think I have the same thing. Okay, think I have same thing. I have a user, I have a customer. A customer is complaining about in three different ways. One is call, I have IVR, and they have service portal, and they have agent. Agent means a person only. They're calling to the person like a customer support, application support person manually, and these people are logging the ticket. Okay, logs the ticket. Let's say logs the number of tickets. Okay, number of tickets. Okay, so all these tickets here it will log, and this will be going to my LLM. Here I have an LLM. LLM. This LLM has to take a decision to route with my service now. Route with my service now. Okay, any use case you can take. Okay, any use case you can take. Maybe here, maybe this not service now or something else. So here it has to. If I directly provide this bunch of or a batch of tickets to my LLM, will it be performed good? No. So here there will be an API. Here we will give all these prompt things. Okay, prompt management. We will have a registry here. We'll maintain it. We'll maintain it like this. Okay, we'll maintain it here. So what I'm telling here, we have a few shot prompting. Here, this will work like, hey, extract all entities from the text. Follow the exact format shown. Like the first example, if a ticket was logged, AWS US East had 3 outages in Jan 2025, then it has to say these things. If GCP Europe was reported one incident in last week, then you have to give output like this. Okay. Now extract from user input. These are the two examples that you have to learn. Similar way you give to the user input like this output. Like however we given already training things to the LLM, right? Why can't it give the out? No, it won't. We have to structure it. Whatever the user input, whatever it is, now it will take a user input, and in this format it will give you the output. It will give you the output. So this is called few shot prompting. A production tip is We use 3 to 5 examples for the classification task, including edge cases in your exam. So we always include the examples to show a very good output from your stage input. Okay. And chain of thoughts. What we will do, will make our model to do some extra work. So this is something a dynamic things. A dynamic things means in the back end, it will dynamically trying to populate or format your input. How? Example, I'm giving analyze this Kubernetes incident step by step. So the error is here pod loop crash loopback issue of a pod Ohm killed event HPA scaling to max. This is an exact problem. Okay. So we said that here identify the primary failure signals, determine the root cause of the signals, assess the blast radius, and recommend the remediation, and think through the each step carefully and before you're proceeding. If you give the same prompt to your cursor will do a very good job to you. A very good job to you. Any problem that you are pasting into the chat gpt, if you are working in the real world, you have some issue, you have one ticket, okay, your manager sets up uh, this issue, can you solve and go try this. It will tell you very clearly a step by step, keep it this an example, and then say that hey, this is my real problem, this is take as an example, take it this as an example prompt to your chat gpt and tell this is my original question. Then in that example manner it will give it to you. Otherwise just copy this, just copy this, keep your problem here, keep your problem here, but you don't know which steps you want. I know only about the problem, but I can't say the steps. Identify the primary failure, determine the root cause. If you don't know how to write the steps, then use the same steps. It will tell you a very clear output to you, a very good output to you. Okay, you just upload log, you just upload log to the chat gpt, keep a log, keep this prompt, it exactly do the exact job to you. So what we do generally, we will just say that log uploaded, hey, this is error came, can you just find out what was the issue. Then ChatGPT, they are managing their own prompt management. Whatever it is understanding, it will give you the output. If you're not controlling the output structure, it will give you bunch of things where you have to read entire thing and understand. At your first glance, you want an error and solution, you can try this. This is chain of thought. Okay, it is chain process. Step 1, step 2, step 3, step 4. It will come like that. And react and pattern. Reason plus act. This is an AI agent. This is an actually AI agent. So we have an AI agent which is connected to the MCP. We uploaded kubeconfig. So my MCP and agent, they connect to the Kubernetes every, and they'll look at the pods, they'll run the kubectl get pods command automatically, it will run over there. Or your MCP connected to the GitHub, your agent is fetching the PRs and looking at and trying to do digest, okay, summary digest, how it has to react. So what prompt you will give it to the system? We will directly say that hey, you are a GitHub expert, try this, get PRs, summarize them, and give the output. Will you be do like that? No, do like this. If you do like that, I'm not telling this is the perfect. You have to test it again. This is testing case also there. We have to test it. You have to test it the output. I'm not telling that this is a perfect output that your system will give with this prompt. No, we have to refactor the prompt. So this is one type of job actually. At domain specific LLM, people are deploying one person dedicatedly work on this. A team of people will dedicatedly work on this. Nowadays, whoever the in the team, whoever data science people or ML people are there, we are only doing these things. But when it is going to production and wide range, we have to manage this separately. What I'm telling here, you are a Kubernetes troubleshooting agent for each issue like thought, analyze what you know and what you need, action, run some commands, observation, fetch some tools or connect with some output logs, and repeat the process and give the answer. So this is what we say in agents, AI ops agents. Okay, like if you are connecting OpenClaw, we can use this. This is a pattern. This is a React pattern prompt will give in OpenClaw. Okay, a real world example. Okay, so there was a bot you can actually do in my YouTube channel. I have created one. You just go to YouTube, or it is there. Just I recommend you to watch this video, please. There was, or this one, or this one. Yeah, this one. Watch this video, please. This is actually tells you how your agent should react on your Kubernetes system. Okay, you have other videos as well here, so just please look at them. And the last, this one also, look at this as well, and many other things. Okay, look at this as well, or there's one more. So there's one more video. Just look at this video. Okay, look at this video also. There is some, I have done some labs over this, meaningful labs, very good labs actually. So that's how this one will be reacting. So like for Amazon Bedrock, okay, Bedrock, LangChain agents, whichever the agents we are writing, okay, whichever the agents we are building, that's good. Okay, the output structure format should be like this. So if you go with the JSON technique, so JSON technique, here you kept in a JSON, it will give you in a very good, because if you give in a XML, if you give in a YAML, if you give in a JSON, your system can understand way more better than the what your normal prompt you are giving. You know, because system knows this structure, right? System can identify, oh, this structure is an XML structure. It's already know that. It's a JSON structure. It's already know. So that it can understand very easily. Like you're talking to me in Telugu rather than the English. If I'm talking to you in Hindi rather than the other language, right? You and me know English, but if you're talking to me in Telugu, which is my mother tongue, I can understand the more better thing. Similar way, so if we trying to say to the system what system knows, then it is very easy to understand to the system, and it can give us good output. So that is what this JSON pattern technique. There are some advanced techniques we do have. Okay. and it depends on your thing. And coming to the version and templates, so we use Jinja 2 templates or we use some other tools. Here you can see in every organization, the big organization, we create the repository like this, a separate repository. A separate repository we create, and this separate repository will have separate CI/CD pipeline. This separate repository will be having prompt, okay, and this is running a separate CI/CD pipeline. In this CI/CD pipeline, we do test also. We do test also, testing prompts, testing output. How, sir? We will do regression test, prompt regression test. What does mean by regression test? We actually send a real request to the LLM. We actually send a real request to the LLM. So with this prompt, my LLM will give you a response back to us. So with this, we'll monitor actually. And we have a versions here. We will maintain a Git versions, hash versions, all this. We'll maintain a versions. Oh, which prompt is giving us very good, nice things. Then we finalize that and we will deploy. So in your development branch, you will do all this. In development branch, you will do all this. And then you will promote to your main branch. And then if you promote it to your main branch, it is deployed into your production. Similar like your DevOps things only. So in your GitHub Actions CI/CD, it will run. So this is how it look like the architecture. Let's say I have an issue for my Zendesk and service now. I took that as an example. Ticket classifier. So I have version 1, okay, v1.1.0, v2.2.0, like this. Summarizer and registry.yml and registry.ym. In this version, I said that system.txt, system prompt, user template.txt, user prompt, config.yml, configuration issues, and example JSON. This is how we define the prompt, system prompt for your backend service after your UI. After your UI, for the backend service, we define like this. And with this, we deploy the backend service. With this, we deploy the backend service. So you can see in the user template, we use this Jinja to template things because it is dynamic things. Dynamic things here, we never write exact things. We leave them. We will leave them. You can see these placeholders. We will leave them. These things are going to fill by your user input prompt. These things are going to fill by your user input prompt, and this prompt will send to LLM. Now you can think you are typing lots of blah things to the ChatGPT, but GPT model behind which is working LLM, it only get what it has to need. Whatever you are typing is trash. Behind the thing, they're actually formulating what GPT needs, what Anthropic needs, and that's how you're getting the output in their point of view only, not in your point of view. You write many things, but whatever GPT wants to give you output, it will give it to you in the same format in a dynamic way. This is how the prompt things will happen at larger LLMs, right? So prompt engineering is not only that we are typing chat in the front side, in UI side. No, back in the process, there's a one more prompt is working based on your input prompt. Okay, this is what happens. Let's take an example here. You can see classify the following ticket type, ticket categories join, and you can make use of zero shot also here. Include examples. Take the examples from the example one. Okay, and uh, ticket title. and written in that category, priority, and confidence. So here we'll give from Jinja to import environment. We write this command. We write this piece of code. This piece of code everywhere is same. Environment load from the prompt. This area there is a user template txt file is there. Take it, take it and render it into ticket type, category, include examples and title. Okay, ticket text. My invoice is wrong. This is going to done dynamically. So we have config driven prompt management. So that means whatever the prompts we are actually giving, so for them we provide in a parameterized way. Parameterized way in the sense we have a model artifacts, right? When we're deploying model in ML flow, we have seen model YML files also, config.yml, outputs.yml, right? Those are model artifact output values. When we're going to deploy also, model artifacts will have those values config.yml. So similar way we can also give to the my prompt that like requirement.txt in your Python. Okay, and your node you have this, right, JSON file. We can give here version, model, temperature, max token, top. The same thing I have written in the inline code in the last lab. Here we are passing through the config.yml, a separate file. We're not giving us in the inline code. We send it separately from outside and we'll deploy in the backend service. So there are versioning strategies. This is up to you how your company is following. Git based versions is every company will follow most of the cases. A semantic version is again it's up to you, like v1.12.2 like this. Above I have created, right, like this. This is the version. And tools we have, these are the tools.
And how do we use this YAML file or the text file within your LLM code, basically?
No, so this is going to be deployed in the your backend service, this one. Okay,
Okay.
so the prompt, it is going to communicate with your LLM, right? So it will
Yeah.
look at these things. However, we do the same sort of things while we're deploying LLM as well. Okay,
Okay. Okay. All
okay.
right. Okay. Okay. Okay.
So from the prompt management point of view, so when I would like to reproduce the same prompts with my templates, then I can use this. So like requirements, I don't want to change every time the requirements, right? I in a separate file in a decoupled manner I can write it them. So I can only refactor the code, not the values. So I
Yeah.
can use this one.
Yeah.
Cool. So these are the tools actually in production level system we are using. Langsmith, costly. Azure prompt flow if you are on the Azure side, okay. Human loop, which is free tier also there and paid also there. You can use both. And port key is a free tier good. You can have a glance on it. Git and Jinja too. Most of the companies will go for this because it's fully in our control, which I shown you the repository directory. Every company will do this. Mostly they'll go with Git and Jinja 2 templates. If those engineers are not comfortable and they wanted to, maybe they have multiple wider LLMs deploying, they wanted to be have a one unified portal. Okay, go with Langsmith or go with Human Loop. You can use these tools. So prompt management, A&B testing, analytics, all this similar things will apply for your prompt management things as well. Okay. The framework testings. So how it actually happened? So this is the code example. I have already built a lab here. So you can copy and paste the same lab. Right now my VS Code is having some other code actually. It is running some other projects. Now I don't want to disturb that. The process is already running in my GPU. Uh, I can run it for next class actually if you want, or you can also try this. Just create this folder in your GitHub, prompt management system, in your local VS Code. Create this file, create this evaluator py, and this one also, and give some prompts. So here it is actually, and this is you are going to run the lab with these things. In every repository in your system, in your company, you will have this. You know what happens? To decide this prompt whether it is working properly or not, you will also run one more LLM as a judge. LLM as a judge also technique there. We run one more LLM to decide one LLM or one prompt, is it working properly or not. That is also one more technique. Here, just give this prompt, apply this template, apply this one, like copy paste this all things, and run in the last that py, run the demo py. See the examples here I'm giving. So this one, run it, it will give you the output. It will give you the outputs to you. So this is exactly lab that you can run. It will work. It's not big thing, but this is how happens in the real world organizations with your prompt managing things. Your prompt managing things. Okay. So this is very, very important if you're writing agentic systems, not only the LLM agentic system. Okay. Whatever model you are running, but ultimately on top of it, you're developing an agent and you're connecting to it, right? Your agent should have this prompt management things. How you will manage, let's say you have different 2 3 agents, like 10 agents you wanted to work back in the process. For 10 agents, how do you manage in distributed mode? How do you manage the prompt things in a distributed mode? Let's say I have 10 agents, okay? Seventh agent, maybe the prompt is not working properly. I would like to fine tune the prompt. From where you will fine tune? Will you go agent code inline, and the inline code in the one file you will do changes over there? No, you have to be decoupled from another repository. You have to just tweak it, then it has to deploy, and the agent has to use it like in a reusable format, like in a modular format. Let me tell you in a diagrammatical way. I have one agent, I have second agent, and I have third agent. Okay, we know that this agents will work in a sequential or a parallel or whatever. Okay, or in hub and spoke manner. So one master will be there, and all are these clients or the slaves like that. So master can command to the agent what you have to bring for me. Then it will formulate and structure and then give it to your output like this. Or one agent will be there, tooling system it will connect. So let's say I have a UI here. You set and it will activate the sub agents. Maybe this is having a sub agents. You can do. So cursor is launched two thing, composer 2. It actually activates the sub agents and good thing. You can go and try and cursor composer 2 model, which is good actually. It's almost good than for GPT 5.4. Try it out. So I have agent 1, I have agent 2, and I have agent 3. In agent 1, agent 2, agent 3, okay, my LLMs are working. So let's say I have connected GPT here, GPT key here, just GPT key, API key. Choosing, I have this core logic which it can work actually over there. Okay, my agent is an application here. It's an application here. It work like that. I have Google. and I have mm, Opus. Okay, Anthropic. Now, okay, it is making utilizing this, and then maybe it will give the output like this to here. So it work in a sequential manner. Okay, it work in a sequential manner, or maybe it route based on the request process. So it not like key agent 1 has to connect to agent 2. No, it can be routed depends on your input thing. Depends on your input thing. Input thing is only doesn't require agent to action over there, and what agent 2 will run over there. Unnecessarily you are paying for that tokens, right? There is no use of agent 2 in the sequence. I given some prompt, my agent 2 is nothing else, no value there. But still my agent 1 is triggering agent 2, and agent 2 is working something, and it is saying that after I processed, after I analyzed, I can't help you, buddy. For that, it's already processed, right? Input tokens are consumed over there. Why are you paying for it? No, I would route it directly to agent 3, where agent 3 is actually create the value for you. So this is how your filters has to be happen here. It has to take a routing system on your agent 3 directly. These mechanisms we have to design in the agents. Okay, we have to design in the agents. Now, maybe I'm doing for OpenClaw. Maybe building this from the agentic core, AWS agentic core and Bedrock with a combination. Maybe I am doing from LangGraph or a QA. If I'm doing from this, I will be managing prompts, right? I will be managing prompt here. I will be managing prompt here. The system prompt, agent prompt. I'll be managing here, and also I'll be managing here as well. Okay, here as well. So let's say agent 2 was not performing well. Not scope got after 6 months, a scope got changed, or maybe the output pattern we need to uh, different. Okay, we need to change it. So this agent 3 is giving an output to agent 2. So the agent 2 is whatever the output given, it has to give to agent 3 after its thing. So because of this output, my agent 3 is not giving a proper output to the agent 1. So this is the last verified agent, and it will do verification and test, then it will send back to this output to the backend system, and this will go and right here. It will right here like this, right here. This is a culprit here now. Okay. This I would like to fine tune. How you will do this? Will you come to this agent to repository? Okay. Will you come to this agent to repository? This is agent to repository or single repository, mono repository only. You'll come to the separate folder here. There is inline prompt things. Will you do changes and you will deploy agent to? Will you do this? So if you're deploying this agent to, your system is something you're disturbing in it, right? Or disturbing in it. So this agent has to use these prompts. It has to connect and go and take these prompts. Okay. So here I would like to, in each repository will you go? I have a repository here for this. I have a repository for this. And I have a repository for this. Will I do direct in the repository, agent repositories? No. What I will do, I'll create one shared repository for my prompts. This is called distributed things. From here, my repositories will invoke. From here, my repositories will be invoked. Here I will do the changes. Here I will do the changes for whichever the agent I would like to. And this is I will deploy. This is I will deploy. I will do some sort of CI/CD things, test, regressions, on agent level, and then I will finalize this. This prompt I will finalize here or here. If you're running very big agentic thing, cursor will do this. Cursor is doing this. They have created rules, skill.md, .mdc files you define in your local, but how it has to react based on it. Let's say Composer 1 and Composer 2, they have two. The Composer 2 will be using the same models of what you are using: GPT, Anthropic, Google, Kimi, Grok, many other, but they are giving you at very cheaper than your GPT. A Composer 2 or a 1 is very cheaper. Composer 1 is not working very good at all. So people are going there, but they're not making use of Composer 1 because it's not doing good job. Directly we are what we're tagging, because of the advertisements and all, we know very good. Opus, we will select the model and we will do code changes directly. It is also in the VS Code. Okay, but you know, you also give uh, Opus selected in VS Code, but your cursor will trigger subagents behind it. Subagents behind it, and it use the same model which you have selected, and they are charging for it. So instead, if you use Composer, it's their headache, this maintaining, but they are not achieving good things. Once they achieve these good things, in the Composer, they are making like this to trigger the sub agents in the backend. They have the cloud agents also. Hmm? Similar way, your this one. If you are developing the same things from your agentic core, stud agents and all, you have to do these things only. It's not like in a single repository, in single like given a prompt, no, deploy it, and one single notebook cell. This is how the real architecture works. This is where we use the prompting things. So that's why I have specially mentioned a separate section for this, how it look like. So this is a lab that you can try, and you can also go and read the notes which I have created from this only. Look at this Depalao docs and this prompt flow and this OpenAI. Actually, these are the actual notes. You can find whatever I'm teaching. Okay. This is prompt thing. This lab you can run. I would say that please run at least one lab from your system and just at least post one of you. This is the output I got in our classroom. Please post your output in our classroom. So do your labs. So after this, we'll be moving to deploying an LLM. I would be get ready one server or a Kubernetes, and we will build an LLM through the GitHub Actions. Or first we manually build it and we'll deploy it and we'll see. Okay, how I should prepare a VM to deploy an LLM. Two things: build an LLM and which format and what procedure I have to take. Building, then I have to make it as a Docker image, or though like artifact is enough. Then deploying, can I deploy directly into my NLP stack, or should I also deploy with a Docker container format? Two things. I'm coming to that point. Once we deploy, we will discuss do your fine tuning and RAG systems. Okay, and monitoring. So this part is also we are covering in the prompting thing. The guardrails also comes in the same, like your output filterings. Okay, content filtering, bias detection, explainability framework. This is also one thing. compliance. We have separate tools for this. Okay, so we can implement some of the gutters, not in the tool wise, but at least in a programmatic way we can implement the guardrails. Programmatic way, not from the tool wise. I'll see the any open source tools is there. We have Qtool, Kivano like that, but I don't know Kivano will work properly. Some other open source tools there, then we'll use. Okay. Any doubts as of now? So even when you are typing any prompt, there are role-based prompt. So role-based prompt means say that you are an senior uh, full stack developer. Okay, explain about this code like this. This is a role-based thing. Okay, this is a role-based thing. And second thing is like you can say few shot. So few shot is like example. I give an input apple, then say it as fruit like this. Okay, and you can say that chain of thought. But whenever you're writing, use this some techniques. What techniques? There's a delimiters. Okay, that means use this, use these things like this and some space. Okay, like this. Use these things. It will actually work super. Okay, and say that example what I can say. Okay, analyze below code and log and return root cause. Simple like this. Okay, when you say logs, say that like this, and error, say that connection timeout. This is your error, and close this, and then say that return. Okay, say this and say root cause and solution. So whenever you say this, okay, whenever you say this, it actually perform super good. It actually performs super good. Let's test with the DeepSeek. Simple. So let's take test with the ChatGPT. Log analysis, connection timeout, network issues, target service not reachable, firewall security solution easily. This is actually a long thing, no? A long thing because I made it to be only given a long thing. So we can also give in the template wise. So template wise, you can also keep the template, but you cannot give in this chat GPT mode or here because if you keep it here, it will be only relied in this template mode only, so which will not good for your wide range of work. So I told you right, there is a types of testings are happens. Testings are like when you write the prompt like this. when you write the testing frameworks, I would say, whenever you write this, you are you are running in the pipeline unit testing the prompts. Okay, so one is unit testing, one is regression testing. If you are LLM ops, LLM engineer, this is your job. And evaluation metrics. Okay, and so basically these three stages will be run. What happens in unit testing? We will see that, hey, whatever the input we passed is output okay. And in regression testing, what we will do, we'll check if the new prompt is broken or old behavior. Is it broken or old behavior? Is it something jailbreaked? Okay, so like this, we will do in a regression testing. Evaluation metrics is we will see after this prompt, what is accuracy? What is accuracy? What is relevance? Relevance. And what is hallucination rate after this actually? This is test goes on. This type of test goes on what? Prompts only. We will run this actually like this. When it is going to be, there are types of judging. Okay. One is LLM as a judge. LLM as a judge. One is human feedback loop. And one is RAG evaluation. So in this, we'll do actually. Okay. So this is how the best things happens in your organizations. So there are many use cases. Even we have offline testing, online testing also. If you are separately from the prompt engineering, then these are all your job. Okay. We have something called predefined data sets, and we have A and B testing in the prompts as well. Which prompt is having 50% and which prompt is having other 50%, and we will do satisfaction level, toxic level, latency level, accuracy level, uh, all these things actually. So how this regex is followed, any regex validation we use, toxic filters we use, output recheck we use, or schema validation we use. All these are techniques. Okay, that comes in our even guardrail also. Okay, example, example. I'll tell you exact a real example you can use in your interviews. Zendesk. Okay, Zendesk. If you give prompt like anything, answer in a nice way or polite way. Okay, politely. Okay, plus use company policy. If I say this policy, if I say this, what happens? We have a version prompts, right? So in this version prompts, it will look for refund and then complaints and then tech issues like this. You can give three different versions, prompts versions. It will pick up dynamically with your filter. Whenever say company policy, it will pick up these three prompts. This is where we use in our IDEs also. IDEs, that VS Code and all, they are using the similar context. Like whenever you ask anything to Copilot, behind the case they are using what? Repo context, file history, and user intent. This is how they manage their prompts in the code generation. Every IDE is working, right? They manage like this. In AI ops, we also do this thing. The advanced Splunk, Neuralink, they are there, right? They also use the same process. So this is, I would like to thought that the real industries are work like this on the prompt managing and prompt registries and prompt template use cases. So I would like to give a wide idea on it. Uh, Maybe you get a question. Okay, okay, brother. So your interviewer is asking questions like this. This is asked actually. You are working as okay, AML, okay, LLMs, okay. You deployed an LLM. How you're deploying? You will say that we actually took a GPT things, or we have already open source models. We trained. We have a separate training pipelines and data sets, and we did the training. And okay, we have a separate pipeline which is going to build and that we are deploying. Okay, where you are deploying? Or maybe we are deploying in the Kubernetes. How you are deploying? In Kubernetes, we have ML servers and we have an NLP stack where there we are deploying. Okay, can you tell me, walk me through the process? They'll ask this, walk me through the process because they also don't know. They wanted to validate you. If you say a proper process, this is how our team is doing. This is how data science engineers are working. This is how we took some libraries. This is how we done some POC. This is how we had this one. This is our strategy. And then we come to this phase where our pipeline will trigger. And this pipeline will build my model, LLM model after the training set completed, and then we do some sort of evaluation. Evaluation is done, we got a good scoring, and we do some kind of a benchmarking within the lower environment only, and then we will finalize that with a call. With a call. Which call? Evaluation call, audit call, benchmark call, whatever the call. Your team people will be in a call. You people will decide that okay, this is good to go. Yes, then triggering the CD pipeline, software build pipeline. CD pipeline. So CD pipeline will be going to trigger which model artifact? The model which you are deployed in your local, not in your local environment, in your this environment, like in your QA environment, where QA regression testings will be your run over there. So once there it will be deployed, there you will do all the sort of things. So there you will actually push some traffic, your internal traffic. You have a dummy traffic, right? You push some dummy traffic over there, you will test it out, you again do some sort of scoring. The same artifact you will promote to the production. You never build again a separate pipeline for the production. There you have a approval process. There it is going to do in a blue-green process. If you're deploying your a new LLM into your Kubernetes or your EC2 service directly, you have two load balancer will work parallelly. And then one is works, then you switch update, you will run one controller over there. And then you will update them. Once you update them, then the traffic will be forwarded to your new LLM. From there, that point, they'll ask, okay, this is the deployment things, infra things are okay, and how does that user is communicating with LLM? And you will say that we have a wrappers, API communications, backend services. Which backend services? Python. Okay, what process you have? UV GUI processes. Okay, where what backends you are running? Transfer, Triton. Okay, then the user request. Can you walk me through how the user request is coming and hitting to your LLM? These are the questions people are asking. With this, they'll get to know you're really working or not. Okay, single notebook will deploy, will could put inline test. Okay, it will give response. Not this one. This is an answer. So I will be giving this interview question and answers in the last. Don't worry. A gunshot things. Almost 200 plus questions are there. If you read them, because we are already having this all idea, very good idea. If you read very good, you'll able to answer anything. So I would. This is a prompt thing I would like to. And the second thing is we have a lab in the next class. Please be available for the lab. And okay, I might be take on Monday class like on 9 p.m. or 8:45 p.m. because one thing I have to again, sir, Surendra sir, I'm actually connecting with one person for the open cloud deployment also. Maybe I can help you in that once I see that you also asked so how we can make it out. So I also uh, helping that person to be deployed open cloud. Maybe I can give you more context for your infra as well with open cloud. Last time we had a discussion, right, sir? How we can
Yeah,
do a duplicate.
OpenClaw install, that's not a problem. I,
No, connecting the
I,
agent, like building an agent with the open cloud and connecting to the tools.
I did that, like I experimented.
Oh, great. Like in local or production system?
Local. I brought a Mac Mini. I mean, I'm not doing it in the production. Production is like very experimentative. So I'm doing every all the experimentations in the Mac Mini. I brought a new Mac Mini.
But I'm going to do on a servers, sir, actually.
VPS, you can do that. See, I mean, we did a experimentation. I'll tell you. Uh, we can do both in the Mac Mini as well as in the VPS also.
Hmm.
Uh, let's take an example of EC2.
Hmm.
So in EC2, you can create uh, what do you say, Cloud Code. Cloud. You can install Cloud Code,
Mm-hmm.
and there is one more called CCO, Cloud Condom.
Mm-hmm.
Okay, and then like you can install OpenClaw.
Hmm.
OpenClaw. Okay, the CCO helps you Cloud Code to run without permissions. Like usually, like Cloud Code, what happens? You need to give all the permissions. You cannot do it. You cannot shut down your system and go away. So Cloud Code will ask so many permissions.
Right.
So you can avoid those things with the Cloud CCO. CCO. There's one more repository called CCO.
Hmm.
Okay, so and I installed OpenClaw. So and I connected Telegram.
Hmm. Hmm. Okay.
And from my local system, so I connected SSH to
Hmm.
EC2.
Hmm.
Okay, like and from my local system, I again, like in my local system, I have this Cloud Code and Cursor installed,
Hmm.
and I am doing all this experimentation inside EC2 also. Like
Hmm.
perhaps you can connect this EC2 with the run pod also. I mean,
Okay.
that is
Okay.
one more
Huh. Okay.
yeah.
Hmm. Hmm.
So what you can do, like first for the installation purpose, like what all the configurations, you can take the help of local Cloud Code and
Hmm.
push that changes to EC2 Cloud Code.
Hmm.
And once the OpenClaw installed, like you have to ask that OpenClaw act as a orchestrator, not as executor.
Right.
Only orchestrator. You can give any API. So
Hmm.
just API, like for me, like I taken this Gemini API key.
Hmm.
That is a minimal billing will happen with the OpenClaw,
Hmm.
and then I have this $200 subscription for the Cloud Code.
Hmm. Hmm. Okay.
Okay. Okay, now I'm asking everything like so. Let us say I'm giving the entire PRD in the local system. I mean, I generating the PRD in the local system, and I'm pushing
Mm,
that to OpenClaw.
mm,
OpenClaw is acting as orchestrator. It is developing entire thing in the cloud code
mm, 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 mm.
overnight. So
Super.
and it is taking only the tokens from the cloud code, not from the OpenClaw.
Right. So like
Right?
sim.
Since I have the $200 subscription, max
Mm,
subscription.
mm,
And there is one more problem. Sometimes it will run out of the tokens. I mean, if you are using a maximum, like it will run out of the tokens, cloud code, I mean to say.
mm,
So what I'm doing, like for the execution part, I'm doing, I mean, since I need the GPUs also, right? When
mm,
I wanted to do SLM development or else fine tuning all these things,
mm.
the cloud code will develop the code, but execution will happen in the run pod.
Okay. So and the run pod here.
Yes.
Hmm.
That way, you can automate everything. There is one more GitHub repository
But
called
but but the problem is like
OpenClaw Research.
code generation will happen. How does this file will move to the run pod and do? So you are transferring this file to be here.
Yes. OpenClaw will do that.
Okay. So you are
We have
also
to give instruction.
okay. You are also saying that copy this CP to here and or move our CP to this server, but you need to establish
Yeah,
these things, the connection thing.
yes,
So
exactly.
this
That you can
connection.
do from the local, all
Hmm,
this thing you can do with the local cloud code, SSH, through SSH.
hmm.
You have to give the permissions.
Right. Hmm,
And this OpenClaw, so I just not experimented, but I came through yesterday. Like
hmm,
instead of directly installing the OpenClaw,
hmm.
you take the NemoClaw.
Okay. Got it.
NemoClaw. So
Yes.
that will protect. That will protect. So Nemo has this claw has the guardrails.
Right.
So OpenClaw has like arbitrary attacks. So
Right.
you cannot protect OpenClaw directly. So
Yes.
instead, you can go with the NemoClaw. So NemoClaw inside NemoClaw, we'll have OpenClaw again.
Yes. Right. So it's
I did
an,
not experiment it, but I have to try.
yes, it's Nvidia's actually. So they were actually
Yes,
promoting a lot. They have a very privacy things
right.
in it. So I
Yeah.
even
So
heard about it.
you can try with UC2. You can do with Hostinger.
Hmm.
For EC2, like I mean, what I would suggest you have to maintain at least 32 GB RAM. Otherwise, this experimentation is not possible. If you go with
I
the 1 GB RAM or 2 GB RAM, and that is quite difficult.
I have already tried with T3 medium of 30 GB storage, which is okay. And I even attached
No, not the
FreeBSD.
storage, not the storage. RAM, you need RAM.
Yeah, so T3 means it is all comes in
Type
4
T3 micro,
right.
T3 micro, I guess.
T3 medium I already did for one of the person, and now it is
Mhm.
going on the dedicated GPU servers. Right now I don't know what is the server thing over there, but
Hmm.
now
No,
so
for that, like what I would suggest you always try if you have another laptop or another machine, try in the local first. If
mm,
everything is working, like see, if you have two workstations, I would say,
mm,
let us say one your normal laptop, another one is like a dedicated laptop.
hmm,
Okay, connect through SSH. The other one is connect through SSH, not directly,
okay. Hmm.
and experiment these things. So once you are able to do this successfully, then go for VPS.
But they have a system already. They have a coder kind of system, and they have this
See, I
VPS
mean, it's
connecting
kind
to
of
that.
a kind of project. I mean, a kind of project. What you want to do that. That
Right.
it depends. That
Right.
also. Like, let us say,
So,
if I want to do a research project altogether,
hmm,
then I will take this auto research class. There is one more GitHub
right.
repository. It is from
Hmm,
University of North Carolina. That
hmm,
is took very popularity. Like in overnight, you got like I think 5,000 stars. The GitHub
hmm,
repository. I
hmm.
came to know yesterday. Like I wanted to test that one as well over the weekend.
Which one? Oh,
Oh,
research.
oh, Auto Research Club. It's based
Yeah,
on the
yeah.
Andres Karpathy's Auto Research.
I even had it. This one.
That
You
one,
are
first
telling.
one. Yeah, first one.
Uh,
So
mine it was
even if you want to
5
develop
days ago.
even if you want to do a complete LLM also, it will do. I'm not
So,
suggesting. I mean, LLM. If you want to build an LLM, like you need a lot of GPUs and a lot of pre-training is required. But what I would suggest you can experiment with the SLMs. SLMs
hmm,
are fine tunings. You can do anything. I mean, if you want to do kind of projects, that kind of projects.
okay. They recently 2 days back only they have published the release.
Right, right. I mean, I'm in the research community. Like I come to know these kind of things very
Hmm.
well.
No, I mean also that, but I'm not actively looking at this busy thing. Uh, okay, fine. So they are they're using cloud skill data. This is cloud. Okay.
This is what I mean. If you want to do research, like not just the scientific research, also. I mean, not just scientific research. You
It's
can do
an
any kind of experimentation.
right. So
It
right
will do
now,
like it is depend on like RL reinforcement
hmm,
learning.
right.
So
So
if you have like a bad score, like it will give you a punishment. If you have a good score,
hmm,
like it will award, and then experiment will go forward.
right, error and trial method. That's reinforced learning.
Yeah.
What this thing is, so we have this is my system, and I'm
Hmm.
accessing their bastion host kind of coder thing. From there, we
Hmm.
are actually accessing the VPS. So in this VPS, we wanted to try installing in a distributed mode, not like we run through one system to another system. There, they have all the systems connected like this in a
Okay.
rack servers, the different servers. They're already running many social media applications
Mm.
with their APIs actually. They have their
Okay.
own connected models. Their
Hmm.
connected models are there, open source connected models are there. So by utilizing this open cloud, they wanted to connect to their different models.
Hey, Rajni, I'll call you in the phone. Like I'm getting a call. I'm sorry.
Okay,
I'll call
okay,
you in the mobile. Give
okay.
me some time.
Fine.
Yeah.
Hey, Rajini, whatever we are discussing it now, right? Do you have the architecture flows? We can easily visualize it because I wanted to understand that. I got it, but somehow, but
I'll
not
give that
100%.
architecture, sir.
Oh,
I have to do it from draw.io so that I can explain you more good. Right
yeah,
now,
right, right.
on the fly, if I draw a diagram, it will look like this only. So
Yeah, yeah, yeah. Okay, okay.
uh, I'll give the open class diagram, LLM diagram, the original diagrams. So yeah. So this for this today. And if anyone having questions, you can raise or you can ask. You can ask me solutions, anything. So this is going very crazy. This gateway, open class gateway, API, AI gateway actually terminology. People will use it to call. So you can use that. You can connect WhatsApp, Telegram, Discord, Slack, anything that your social things. It's working very good. You can also make use OpenClaw in your internal system as well, and under enterprise in your private network. That is
Yeah,
working super
but
good.
still there is some the security is care about that, isn't it?
No,
I mean,
until
depends on.
it's an open source, sir. You're just downloading it. That's why you need to run some security walkthrough towards it. You just
Yeah.
install some tailscale, tailwind like that. Sorry, tailscale things or headscale like that. You connect your system, you keep it in your private network, and then you host it. It will work inside your network. It will be not having any internet connections. Your only agents will have the internet connections. Even your private agents kind of thing also you can build. What Cursor is doing right now, they given private agents. Cursor private agents. So private agents are there. So if you are running on your environment, cloud based thing, within your VPC only Cursor will work. Never get interact with the internet. So like within your network only it will work. Like so a system that will secure and isolate in your virtual machines, managing coding tasks and executing the terminal command. There itself only. So like this also we can build. There are open cloud within private only inside the network. So before that, I would always say that open cloud libraries and the frameworks you should at least run with your SNCC or your Trivy and just try to find out any vulnerabilities are there in it. If that can be fixable with our developers, fix it and then go and run it.
Okay. Okay.
Yeah, sir. We need to run. Okay, for POC purpose, we are directly taking that repository, cloning, and just okay, we are doing. But at least we can uh, run some security scan on it. Then it'll good to know uh, like that.
Right.
Okay. Okay. Thank you all. We'll meet in next class and same time.
Recording stopped.
If you have any questions, you can ask me. I'll just have to join another call. I'll dropping. Okay. Thank you, everyone.